question is lean air fuel mixture is required for. It means what is a requirement for lean air fuel mixture. So first of all we have to understand what is the lean air fuel mixture. So before understanding lean air fuel mixture, I am giving you answer of this question. Lean air fuel mixture is required for crushing. What is crushing? Crushing, or either it's be called constant speed condition. In this condition, engine is already warmed and the fuel mixture ratio is near to the theoretical air fuel ratio. So friends, lean air fuel mixture is required for crushing. It means constant speed condition. What is crushing? Crushing is the condition of engine where engine already warm up and the fuel mixture ratio is near to theoretical air. What is theoretical air? Theoretical air fuel ratio is 14.7:1, where 14.7 is air and 1 is fuel. It is the ratio. Okay. So first of all we have to understand what is the air fuel mixture ratio. The air fuel ratio is the ratio between the mass, air and the amount of fuel. This ratio needed to burn well. Okay. The fuel and air. It should be burned well, fuel and air. If the ratio is richer or leaner, the engine will not burn well the air fuel mixture, that causing bad combustion stage. Theoretical air fuel ratio is 14.7 amount of air needed to burn well, 1 part fuel. But at some conditions, not all fuel can be mixed and vaporized with air. Rich air fuel mixture means the amount of air less than theoretical air fuel ratio. Lean air fuel mixture means the amount of air greater than theoretical air fuel ratio. Theoretical air fuel ratio is 14.7:1. At a starting condition, all engine components such as cylinder head, cylinder block, intake manifold are on the cold condition. Then the injector will following condition to spray the fuel into combustion chamber. So the situation of the air fuel mixture in the combustion chamber becomes lean. That is mean rich air fuel mixture needed to get the best perform to a starting engine. At warming up condition. At this condition, coolant temperature are still low and make vaporized of the fuel becomes worse and also causing of ignition worse. So in this case also the rich air mixture is still needed. At accelerating condition. At this condition, the accelerator pedal is depressed. Of course, more amount of air comes into cylinder, but the fuel late following air mass due to load change on engine condition. In this case, more fuel needed to inject to the mixture or a still rich air fuel mixture needed. At crushing or constant speed condition. I have already explained about this. At heavy load condition. At the heavy loads, engine produce more power to run the vehicle and little bit richer fuel mixture ratio supplied into the cylinder. In this case, why only little bit richer air fuel ratio needed at heavy loads condition? Because to reduce the burning temperature and make sure that all of the air is comes and burn well on the combustion chamber. At deaccelerating condition, at this condition the accelerator pedal going to release, that is mean no output power needed from the engine. So the fuel will cut off and decrease the fuel supply to the combustion chamber. In this stage will clean the exhaust gases as well. Okay. So this is the first question explanation for air fuel mixture. Next question is the air fuel ratios used in the normal operation of SI. SI means spark ignition and CI engine. means compression ignition engines are. In this question asking, what is the normal operation of SI and CI engines in respect to air fuel ratio used? So that is excess air for compression ignition engine and around a stoichiometry for a spark ignition engine for SIE. Okay, so remember always. Next question is, in practice the pressure rise in an SI engine during combustion is lower than that in an air standard Otto cycle for the same heat input because of. In this question asking, why the pressure rise in an SI engine during combustion is lower than that in air standard Otto cycle for the same heat input. Why? Because of. Answer is variable specific heat and dissociation. Okay. Next question is, the following volume in meter cube of air is required for consuming 1 liter of fuel. Why a 4-stroke engine? So volume should be 9 to 10 meter cube. Answer. The fuel consumption of diesel engine is not guaranteed at 1/4 load because at such low loads. Question is, fuel consumption of diesel engine is not guaranteed at 1/4 load because at such low loads means 1/4 load means very less, 1/4 load for fuel consumption of diesel engine. Answer is the small difference in cooling water temperature or in internal friction has a disproportionate effect. Next question is, the air fuel ratios used in the normal operation of SI and CI engines are. So friends, air fuel ratio used in the normal operation of SI and CI engines are excess air for CI and around a stoichiometric for SI. I have already explained this previous question. Why? Explanation is once more. A compression ignition engine runs all the time with lean air fuel mixture. Lean air fuel means theoretical air should be maximum. Okay, linear. And when will we reach a air fuel mixture? Means theoretical air should be less than. In compression ignition engine runs all the time with lean air fuel mixture. The value of the equivalence factor depending on the engine's operating point respect to speed and torque. The value of the equivalence factor depending on the engine's operating. The reason for this is the working principle of a diesel engine. Controlling load not through air mass, which is always in excess, but through fuel mass, that is fuel injection time. In a spark ignition engine usually run on gasoline. Gasoline means petrol fuel. The air fuel ratio of the SI engines varies within the range of 12:1. It means it is a reacher because it's less than theoretical air. That is, theoretical air will be always 14.7:1, but in the reacher it is 12 only, 12:1. So it's reacher, and lean it should be maximum than theoretical air, that is 20:1. So it's lean. Depending on the operating condition of the engine, it means depending on the operating condition means temperature, speed, load, etc. Okay. Next, modern internal combustion engines operate as much as possible around the stoichiometric air fuel ratio, mainly for gas after treatment reasons. In practice, the pressure rise in an SI engine during combustion is lower than that in an air standard Otto cycle for the same heat input because of. Also given, Otto cycle is a theoretical cycle, whereas in actual cycle there will be phenomena such as variable heat and dissociation due to which there will be some heat loss as well. It results in less pressure rise as compared to Otto cycle. Question is knock rating of an SI engine is determined by matching the performance of the engine with a mixture of answer is isooctane and normal heptane. Question is knock rating of an AC engine is determined by means how we can calculate, yeah, we can recognize about knock rating of an SI engine by matching the performance of the engine with a mixture of isooctane and normal heptane. So octanes are a family of hydrocarbons that are typical components of gasoline. They are colorless liquid that boil around 125 degrees centigrade. One member of the octane family, that is isooctane, is used as a reference standard to benchmark the tendency of gasoline or LPG fuel to resist self-ignition. The octane rating of gasoline is measured in a test engine and is defined by comparison with the mixture of 2,2,4 trimethylpentane, isooctane, and heptane that would have the same anti-knocking capacity as the fuel under test. The percentage by volume of 2,2,4 trimethylpentane in that mixture is the octane number of the fuel.